Russia's new two-seat Su-57D fighter is emerging as more than a combat trainer, with TASS reporting on May 25, 2026, that the aircraft could function as an airborne command node, able to direct drones, missiles, and manned aircraft during combat operations. The concept signals a shift in Russian air power toward networked warfare, where the Su-57D could coordinate an entire tactical strike group in contested airspace, while reducing dependence on vulnerable ground-based command links. The aircraft's second crew position is designed to manage sensor fusion, UAV coordination, target assignment, electronic warfare, and real-time battle management, while the pilot concentrates on flying and air combat. Combined with systems such as the S-70 Okhotnik UCAV, potential unmanned Su-75 variants, Kh-69 cruise missiles, and long-range air-to-air weapons, the Su-57D could become the centerpiece of a Russian kill web built around distributed sensors, autonomous platforms, and long-range strike coordination. TASS Russian news agency reported on May 25, 2026, that the twin-seat fifth-generation Su-57D fighter jet could be used as an in-air command post for directing combat, giving a commanding officer a direct airborne view of the tactical situation. Sergei Bogdan, chief pilot of the Sukhoi Design Bureau, stated that the twin-seat version has much wider functionality and interaction capabilities with other aircraft, a statement that changes the interpretation of the program. The Su-57D is no longer only a two-seat derivative of the single-seat Su-57 or a possible combat trainer. It is now emerging as a potential aerial headquarters, able to control more than drones, including unmanned combat aircraft, long-range missiles, and manned aircraft within a single tactical air group. In this configuration, the second crew member could become an air network operator, responsible for managing data exchange, coordinating UAV operations, assigning targets, and supporting real-time battle management during high-tempo air combat. The aircraft completed its first test flight, confirming the existence of the two-seat Su-57D and opening a new phase in the evolution of Russia's fifth-generation fighter program. The new version reveals major design changes compared to the single-seat aircraft, including an extended canopy and a raised rear cockpit for the second crew member. This redesign gives the fighter a distinct external silhouette, while preserving most of the original Su-57 airframe architecture, including its blended fuselage layout, twin-engine configuration, internal weapons bay concept, and low observable shaping. The added crew position is not only intended to support flight operations, it also gives the aircraft a more specialized mission management role. The second crew member can help supervise combat operations involving unmanned aircraft, including future missions with loyal wingman drones and unmanned combat air vehicles. This configuration is expected to reduce pilot workload during complex missions, in which sensor fusion, threat reaction, communications, navigation, electronic warfare management, and weapons employment must be coordinated simultaneously. The new development is that the Su-57D could control more than drones. Its rear cockpit may become a tactical battle management station, allowing a commanding officer to supervise several categories of airborne assets, including UCAVs, unmanned fighter-type platforms, cruise missiles, and long-range air-to-air weapons. In aviation terminology, the aircraft could act as a forward airborne command and control node, combining tactical data link management, off-board targeting, cooperative engagement, emission control, and airspace deconfliction functions. The front seat pilot would remain focused on flight path control, aircraft handling, air combat maneuvering, defensive counter-air reactions, and weapons release, while the rear seat operator would manage the wider combat network, assign targets, coordinate unmanned aircraft, monitor the tactical air picture, and update the mission flow according to real-time changes in the battle space. Sergei Bogdan's comments about radio interference are central to the operational concept. He explained that command from the ground can become difficult when personnel are thousands of kilometers away, and radio interference forces crews to switch between communication channels. Placing an experienced commander inside the Su-57D would allow the air group to react faster to the surrounding environment, because the commander would be flying with the formation and could make decisions based on what the aircraft and connected platforms are detecting in real time. In a contested electromagnetic spectrum, this could reduce dependence on remote ground control, limit the effect of communication latency, and preserve tactical initiative when jamming, data link disruption, frequency hopping, or satellite communication degradation affects the air operation. The imagery associated with the Su-57D gives this concept a broader operational meaning. On the outer side of the vertical stabilizer, a marking appears to show several objects around the Su-57D. Based on their visible forms, the upper object is most probably linked to an unmanned version of the Su-75 Checkmate. On the lower left side, another shape appears to correspond to the S-70 Okhotnik unmanned combat aerial vehicle. Below it, the silhouette may indicate the Kh-69 stealth air-to-surface cruise missile, while another lower object may correspond to an air-launched ballistic missile, or Isdeliye 810, which is considered a further development of the R-37M long-range air-to-air missile. This visual grouping suggests a concept in which the Su-57D is placed at the center of a multi-platform air combat architecture, not only beside one loyal wingman, with the aircraft potentially acting as the airborne coordinator for unmanned fighters, UCAVs, standoff weapons, and long-range intercept missiles. The possible Su-75 Checkmate connection is important for future air superiority tactics. If an unmanned version of the Su-75 is developed as a loyal wingman or autonomous combat aircraft, the Su-57D could use it as a forward sensor, weapons carrier, decoy, electronic warfare asset, or penetration platform. Such an aircraft could fly ahead of the manned Su-57D, expose enemy emitters, extend radar and infrared search coverage, or enter threat envelopes considered too risky for a crewed fighter. The rear seat operator could supervise route changes, target handover, engagement zones, and formation geometry through secure tactical data links. This would give Russia a way to generate more combat mass in contested airspace without placing additional pilots in the highest risk sector of the battlespace. The S-70 Okhotnik would create a heavier UCAV layer within the same air group. Paired with the Su-57D, it could support reconnaissance, strike, electronic attack, deception, target acquisition, or suppression of enemy air defenses, while the crewed fighter remains the airborne command aircraft. The Kh-69 would add a low-absorbable standoff strike option against command posts, radar stations, air defense batteries, aircraft shelters, logistics nodes, and other high-value ground targets. Isdeliye 810 would add a long-range beyond visual range engagement capability against high-value airborne assets such as tankers, airborne early warning and control aircraft, intelligence platforms, and command aircraft. Its official specifications have not been disclosed, but open-source claims associate it with a possible range of up to 450 kilometers and a speed of around Mach 6. In this architecture, the Su-57D would not simply launch weapons. It would operate as a manned combat director, coordinating sensors, shooters, unmanned platforms, and long-range effectors across a wider kill web. For NATO and the United States, the Su-57D concept points to a more complex Russian approach to air superiority, where the threat is no longer defined only by the performance of a single fifth-generation fighter, but by the networked formation operating around it. Such a formation could include unmanned fighter-type platforms, heavy UCAVs, standoff strike weapons, long-range air-to-air missiles, passive sensors, and resilient communications links. Future counter-air missions may need to identify which aircraft is acting as the airborne command node, which contacts are decoys, which platforms are unmanned sensors, and which assets are carrying long-range weapons. This would increase the importance of electronic attack, cyber effects, passive detection, data link disruption, counter-UCAV tactics, and long-range counter-airstrikes designed to break the command network before it completes the targeting cycle. China will also watch this development closely because it is already moving toward two-seat fifth-generation air combat concepts with the J-20S. The Su-57D indicates that major air powers are converging on a similar tactical model, in which a crewed fighter no longer operates as an isolated platform, but directs a distributed formation of unmanned aircraft, weapons, and sensors. Future air superiority will depend not only on radar aperture, missile kinematics, thrust-to-weight ratio, or maneuverability, but also on software-defined mission systems, cockpit workload distribution, autonomous control, secure communications, electronic protection, and rapid data circulation. If Russia can connect the Su-57D with unmanned Su-75 type aircraft, S-70 Okhotnik UCAVs, K-69 cruise missiles, Isdeliye 810 missiles, and other airborne assets, it could move from platform-centered combat to network-centered combat. The Su-57D now appears to represent a shift from a twin-seat fighter project toward a possible airborne tactical headquarters for Russia's future air combat formations.
Its second cockpit could allow one crew member to fly and fight the aircraft, while the other manages the air network, coordinates UAVs, distributes targets, and supervises missile employment across several platforms. The concept still depends on secure data links, resilient communications, mission software, cockpit interface design, drone availability, operator training, and squadron-level integration. Yet the direction is clear. The Su-57D is being positioned as a command aircraft, able to control more than drones. And that could alter how Russia, NATO, the United States, and China plan future aerial tactics and air superiority strategy in a contested battle space.